Hi everyone, and welcome to the episode 4 of Machine Learning with R, a really fantastic journey. I'm Hamid Reza Bolhassani, PhD of Computer Engineering, researcher, data scientist, and founder of DataBiox. I'm really happy to see you again in this episode. So, as you remember, in the previous episodes, we already covered regression and clustering. We have discussed a lot about K-means and run some codes on iris dataset. But one thing that remains from the last episode was PAMK clustering. We already covered PAM, but in this episode we want to cover PAMK, and I want to remind that the nice reference for this lesson and these codes are these document from Yan Changzhou. Yang Zhao. And here you see that let's go to page 22. Yeah, we already covered this PAM clustering in the previous episode, and it was very interesting. We see that these clusters have been made, but in this episode we want to see what is PAMK. It's another type of PAM. You know what was the PAM? Partitioning around the medoids. Yeah. And what is the difference between this and this PAMK and PAM? Yeah. The difference is that here we don't set the number of K, and it will by itself, the algorithm will find the optimum number of clusters. Okay, so here you see that here we don't define the number of clusters here. You see, just we put the data frame here, but if you compare it with PAM, you see that here we also set a number by experiment about the number of clusters. For example, we set 3 here. You remember that I ran this code for empty cars dataset and test 3 and 2 and 4 as clusters, and we have checked the results. Yes, so here we see that for PAMK the algorithm itself will define the number of clusters. So here let's also refer to this documentation, nice documentation from rdocumentation.org. PAMK is partitioning around medoids with estimation of number of clusters. So we see that this calls the function PAM or Clara to perform partitioning around medoids, clustering with the number of clusters. This is very important. Estimated by optimum average silhouette width. Yeah. So here is the difference, and it is also it's very interesting and nice. So let's check that how it works. So first of all, we should define this library. If maybe you face with an error, you should install it if you haven't already installed this library. Okay, so here we will say library fpc. I already installed it. If you don't have it, just install .packages and then fpc. Okay, but I already have it, so no need. And library fpc, yes. And then what we wanna do is to run PAMK algorithm on iris2. You remember iris2 is a copy of iris that we already made it in the code in up. You see, we already made it in the previous episode. So let's see PAMK dot result. We will put the result of PAMK on iris2. Yes, So it's nice. So right now PAMK result has some uh, features and value in it. One of it, as we expect, one of its more important value should be the number of clusters. So PAMK dot result and $, yeah, NC means number of clusters. So it's very interesting for us that what would be the result, how many clusters it have find. Yeah, we see that 2 clusters. So you remember when we set by ourselves, we set it to 3, but here it suggests to 2. And I'm very curious to check it also on empty cars. Yeah, you remember the empty cars dataset? Again, head empty cars, and you see this. So let's check with another parameter here, sorry. Yeah, PAMK result 2 on empty cars, and let's check PAMK result 2, how many clusters for empty cars. You remember we have tested 2, 3 and 4, but you can guess which of the number is better for this problem. Yeah, we can see this 2, but maybe for some problems you can find another number of clusters we can test on other data sets. Maybe in the next episodes I will show you some other examples. So let's continue here. So we found the number of clusters, and here we want to check the results of this PAMK clustering with the original one, the species of iris dataset. So let's check with this code, table PAMK dot result this this PAM object, as you see, yes, PAM object, and then here we have clustering. Then here we will compare it with this iris species. Yeah, species, and then run. Yeah, you see that you remember that we already have 2 clusters for this algorithm, and these are 2. We see that for Setosa it's working great, and just 1 overlap with versicolor, and for the first, and this is for the second. It put the versicolor and virginica in another group. Yeah, so let's see another thing. We want to check the plot. So here, but this code has a little problem. I will show you. If you just run this plot PAMK result, you will face an error. Plot PAMK dot result, we will face with an error like this. Yeah, so we want to just correct this with PAM object. Yeah, and here it says that he hit return. I will hit return. Yeah, it works nice. We see that two clusters are here, and these 2 components explain 95.81% of the point variability. Okay, and we can also check it on the empty cars. You remember we have this for PAMK results 2. Yeah, oh sorry, it was another it was another thing for the previous one. Let's check this. Yes, we see this for empty cars, and again when we hit enter, it will show us the silhouette plot. You see, and we remember that the value of SI, if the value of SI is greater, it means that the clustering is have been done better. So let's check again this for iris dataset. Hit enter, we see first this, and again hit enter, and we see that, yeah, 2 clusters. We see that SI is a 0.81, that it is good, it is great, and it is 62, not bad. Okay, so it was the result. Yeah, the result of clustering you see here. PAM, in this example, the result of PAM seems better because it defines the 3 clusters corresponding to 3 species. Here we have, yeah, a one, yeah, we see that this 95.8, yeah. Okay, so, and yeah, this is in this example, result of PAM seems better because it defines 3 clusters corresponding to 3 species. And note that we cheated setting K3 using PAM, which is already known to us as a number of species. Yeah, this is also the point. Okay, so it was a short episode for just introducing the PAMK and its differences with PAM. In the next episode, we'll cover DB scan, density-based scan, and clustering with R, and many other interesting things. And I hope you enjoy it and would be useful and informative for you. And hope see you in the next videos. Bye.